बना के सेव कर दिया है, आप बस बता दें कि उनको करना क्या है।
पता नहीं है, जिसको जो मन चाहे। हाँ, এসছে? ও উঠছে, ঠিক আছে, আমি ছাড়ছি। হ্যাঁ, পড়ানো শুরু করছি। হুম 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 It's really warm. This one. और ये नहीं काम करता है, ये बंद है, बंद है ना? या बस बस। Okay. Shall I start? Yeah. Okay. So I'm going to a little bit recapitulate what we have done. Started raining. So, yeah. So it would evaluate how many people sleep and how many doesn't. Yes. The control group should have shoes and the treatment should have slipper. So given this, we are going to talk about the DID more, and I'm going to introduce slowly the concept of DID more in terms of the panel. Okay? So recall our potential outcome y1, y0. We had a treatment indicator which is W belongs to 0 and 1. 1 means treatment is taking place, and I'm going to think of ATE, ATT, and ATU, average treatment effect of untreated, of the treated, and overall average treatment effect. So note ATE is nothing but expected value of y1 minus y0. So the average gain if I can move all of you in the other group, nothing more than that. Clear? So ATE of the entire population, I can express this as a weighted average of what? Of two different groups. One which is remaining as untreated, which is the ATU, and the other which is the treated, which is the ATT. And the way I can then think of ATE is nothing but weighted average of ATU and ATT. I think that should be, yeah, ATU and ATT, where rho is the respective weight that I have assigned to one of them. Clear? Fine. Recall your conditional mean assumption, which we have done before, and then the assumption 1 is conditional mean independence, expected value of y conditional on w is equal to 1, which should be equal to expected value of y1 when w is equal to 1, and similarly it goes in terms of y0 also. Okay. Then I am going to think of that assumption 2, which I am going to think about it is in terms of non-overlapping region. So the overlap in terms of the covariance distribution. Clear? Fine. So the way I want to think of that overlap implies what? Overlap implies something like a control unit in the population. We can get something very similar, almost essentially with the same value in the treatment group of the covariate. So I want to think of that I have a control unit, I have a treated unit. I have some covariates, the covariates assembles the treated very closely. So it is something like cloning, right? In some way you want to clone the covariates across the two groups, which is the treatment and the control group. Clear? Fine. So given this, I then want to think of DID is what? Is nothing but y11, average value of that, minus y10, that's my treated group, before and after, and then take the difference between the one which never got the treatment, that the control, for them also in the first time period 0, 0, and the second time period which is 0, 1. Estimate the treatment effect by differencing changes over time period. So I can think of that post is nothing but takes the value of 1 when the treatment start taking place. Then I have the treat which varies across I, because somebody gets it, somebody doesn't get it. My main interest would be in terms of tau, which is the interaction of those guy who got the treatment. Clear? Fine. And then my UIT is my error term. So the policy analysis in terms of the panel, so I can think of that I have YIT which has a constant which is eta 1, and then I have series of these time dummies which is D2T to DTT, and then WIT is my policy variable, AI is nothing but unobserved heterogeneity, and XIT is nothing but the set of controls. Clear? Okay. So note, WIT is the policy variable which is binary in nature, and the coefficient associated with WIT, which is beta in my example, that's estimate the average treatment effect. So I allow the WIT to be systematically related with my unobserved fixed effect, which is alpha I or AI, and we can estimate this regression either by a fixed effect regression or a FD transformation, simply because in both ways we can eliminate the impact of the unobserved heterogeneity, which is AI. Clear? So given this, you can think of why the time dummies should be there. The way we want to think about the time dummies, that as I did in a two-way fixed effect model. Clear? So any other thing other than the actual treatment can affect the outcome, and hence I want to control for it. Okay? So the way then I want to think about it, we can also include lags of policy intervention. So I can have WIT minus 1, WIT minus 2, and in the similar way, not only in the backward, at some point of time I'll do that, I can include the forward one of them. So WIT plus 1 up to WIT plus 2, and so on and so forth. Clear? So I not only can include the lag, but I also can include the leads of the variable. Okay. But to be specific over here, I just want to start with a static kind of policy intervention, which is my WIT. Question? No? Fine? Need to be careful. What am I going to be careful with? I'm going to be careful with the policy variable, whether it reacts to the path shock or not. The way I can think of YIT is poverty rate and WIT is some measure of the government assistance. Why I need to be careful of WIT, whether it is reacting to the past shock or not, I can think of that if there is a large shock in poverty in year T, then it could tell the government that increase your intervention in year T plus 1, right? Something like, a lot of times health programs are being introduced in those districts where the infant mortality rate is very high. So if there is a sudden jump in the infant mortality rate, what you observe the next year, those turns out to be the targeted district. But then I can think of that those districts became targeted district because there was a sudden jump in previous year in the infant mortality rate. The same thing you can think of about the crop assistance program, or something like what he is doing with the Sula wine in Maharashtra or in Pune, near about Pune, right? So, Nashik. Right, right. So that's how it is, because bad weather can affect the too much rain can affect the wine, and therefore if there is too much rain next year, the government, if the meteorological survey or meteorological department expects again the same amount of rainfall, then they know that the wine producer would get affected, and hence they may increase something like the policy intervention so that to protect those guys. Otherwise the suicidal rate would increase among the farmers, right?
So in this case, we don't need control and TB.
You can. That's not a problem.
Then we have to interact it with the policy.
Yeah, yeah. No, I mean, control can be there as it is. But the way I'm thinking of that, I start the policy intervention or I increase the intensity of the policy because I know that this has happened this year. So the increase in terms of the assistance or in terms of the intensity of the program increases simply because I had the prior information that these are the districts where the poverty was or jumped, or infant mortality jumped compared to others. Yes.
So here the intervention is not random.
Of course not. Because I am thinking of good point. So I'm thinking of as it has happened yesterday, it could have happened today, and hence I need to be better proactive, given it has already happened today, and especially that happens if the election is around the corner.
So this intervention
Clear?
also may differ spatially, this intervention.
Of course.
Temporally and spatially.
Of course. So it goes like I and j, and it can go between t and t minus 1. Spatial is a different ball game, and I am not considering that here. But yes, sometime back I had a small meeting with Preeti, and then we talked about the spatial dimension of it, right? And yesterday we met someone. I really like our small interaction for half an hour. Munish Goel from hydrology. So that's how it is, because he's working on some Narmada project where the water release or measurement of water in Narmada is a problem, and that would depend in some way that which dam should release how much, how many liters of water, and there could be a politics of water release even involved over there. Okay. So anyway, so let's come to our point, right? Not Manish and not Preeti. So testing for feedback of the error to the policy. So I want to think of that there would be an impact of the feedback of the error. Remember what I started with, right? I am increasing it because I know I have the prior information, okay? So given that, assume t is equal to time period 3. So I have those dummies, then what I do, WIT and WIT plus 1. So I do not only include the impact on when treatment took place, I also use the lead of W, which is basically WIT plus 1. I estimate the model with perhaps cluster robot statistics, and I want to check not the beta but the delta over here, not the beta but the delta over here. If I want to go ahead more, then I can think of t is equal to 4, and then I am interested in the coefficient or the estimate of WIT plus 1 and WIT plus 2, which is delta 1 hat and delta 2 hat, and I would test whether delta 1 hat and delta, sorry, there is a typo. So there is a delta 1 hat and delta 2 hat, whether they are significantly different from 0, and there could be two different tests. One is a T, where individually I am testing delta 1 hat and delta 2 hat, or I can jointly test using an F test in terms of whether the both of them simultaneously equal to 0. Okay, so that's what the F statistics tells you. Yes.
So what is t is equal to 3, t is equal to 4?
The time period.
Time period.
So I have
So it will be some like income of the farmer and time to income of the farmer.
Income of the same farmer, you go and survey them over a period of 10 years or 3 years or 4 years, whatever it is. Okay, clear? Yes. So then what I then want to think of, that this is nothing but known as in the literature a test which we call as falsification test. Why is it a falsification test? If the forward policy variable is statistically significant, then there is a potential feedback from the error term to the public policy maker or something like the policy formulation. Recall my example of infant mortality, right? And you will see that falsification would increase, especially in case of India, when there is election in corner, right? Because that's one of the way to think about the falsification, or the intensity of the falsification would increase in during that time, right? Clear? Lot of freebies would be there, and the political parties basically doesn't compete for infrastructure development, but they do compete for the freebies in during the election, right? They don't care what has happened last 5 years, but as the election is on the corner, so all I want to do, let's get a competition in terms of distributing the freebies, right? That's what happened, right? Clear?
And if you want to look at the backward one, then we will have WIT.
T minus 1 and things like that, right? So you can think of, I can do both. I can either regress TFP of IT on export IT minus 1, or I can regress TFP of IT plus 1 on export IT. So it doesn't matter whether I am going to do in some way lead or the lag, but in this case, because I want to examine what has happened on what would happen, right? What had happened on what would happen or what could potentially happen, I am including the lead instead of the lag. Clear? I need to drink a little water.
Why it is called falsification?
Because it has happened, and that is why you are doing it. It is nothing like, you do it because you really want to do it. So basically, the way to think about it, I'm doing this intervention because I know this has happened, but I don't have the objective of doing this intervention, right? I'm going to stop this water because I know last year I did not stop the water, hence there was a flood. I'm careful because my experience, and I know from June to August I'm going to stop this. Clear? Which is nothing but to do with anything else rather than your past experience, which is the error leading to the policy intervention. Yes?
So the WIT is the
Indicator variables.
Indicator whether the person
Yeah.
statement or not received.
Yeah.
So you're written WIT plus delta WIT plus 1.
Yeah.
What is this WIT plus 1? Time period
Next time period. The lead one.
was in treated group or
Yeah. What the same thing has happened or not. Okay?
So generally a person generally it will be 1 only, or it can change.
It can change to 1 0, it can change to 0 to 1, it can remain as 0 0. Right? The other way to think about it, I want to think about it more in terms of heterogeneous trend model. What does the heterogeneous trend model implies? That I want to think of each group represent a group specific trend, right? So people from JNU has a trend of doing some kind of research. People from IIM has a training of doing some kind of research, so on and so forth. So I am grouping them across your background, whether you are coming from JNU or IIM or IIT, and hence I have group specific trend, which is nothing but your unobserved heterogeneity multiplied with the T, right? Clear? So it is nothing but the group specific trend. So what we want to then think about, here we allow the policy intervention to be correlated with both. What are the both factors? First, I can think of there is a level difference between the cross-sectional unit, which is captured by my AI, and then by the trend difference, which is being captured by CI times tree. So one way I can think about, I have both the AI and the CIT to allow for the policy intervention to be correlated with both the level differences as well as by the trend difference. What I can do in this model, I can take the first difference of it, and then what happens, note the CIT or Ci times t becomes something like an constant, which is nothing but individual fixed effect, because what you have in time period t is Cit, what you have in the next time period is Ci t minus 1, Cit minus Ci times t minus 1, Cit cancels each other, and you are ending up with Ci. Clear? And so we go back to the first model by just simply taking or take care of the heterogeneous strain in terms of the first differencing, and then I can only do it, recall, if I have t greater than equal to 3, because otherwise I cannot do the first difference, because I end up with t is equal to 2 and I have before and after. Clear? Fine. So at least I need t is equal to 3.
So here the third point you have mentioned that the we allow policy intervention to be correlated
With both
both here in the sense
the unobserved heterogeneity captured by AI and then group specific trend, which is nothing but Ci times t.
AI is the error term.
AI is my individual unobserved heterogeneity that we did in case of fixed effect model or any panel data model.
So here we should have 3 time period data.
At least, because we are taking the first difference. Clear?
In this domain which we have,
Yeah.
when we take the first difference, what would be remain?
Yeah, it would go away. But it would like what? 2 minus 1, 1, 3 minus 2, 1. So it is nothing but your eta in an overall constant. Right? Okay. Consider now which we did before, that we have 2 time period t is equal to 0, t is equal to 1, and I want to think of this is the one where the policy change took place. 2 group of people, A never treated, my control, B is the treated. I did something like a specification, yit is equal to beta 0 plus beta 1 dB, that means I am in the control unit. Beta 2, I received the treatment and my interaction term. Here all I want to think of that my indicator variable 1 t is equal to 1 is a post period dummy. dB is nothing but whether I belong to group B, which is my treated group, and in this particular case again I would be interested in the coefficient of the interaction term, interaction of the intervention given the fact I belong to the treated unit. Clear? Fine. So note what would be the thing I can think of. If I go back and start taking the expectation that nothing is there, so I can get something like beta 0, expectation of yt, assuming expectation of uyt is equal to 0. So when t is equal to 0, for the control I get beta 0. When t is equal to 1, if I go back, I have this guy beta 0, of course, and then I would get beta 2. Right? And that's what my slide says. Now, for the treated, what would happen? For the treated, I will get the beta 0, of course, and then beta 1 is the incremental effect arising from the fact that I belong to the treated group. So, without intervention, it would be beta 0 plus beta 1. Clear? So then if I go and now the treatment take place, then what I would have is basically my beta 0, I already have beta 1, treatment took place beta 2, and then beta treatment. Right? Clear? So that's how I want to think about it. So expected value of EIT comes in 4 cells, one for t is equal to 0 and t is equal to 1, and then the other in terms of the control and the treated. Clear? So note, for the control I can think of beta 0 plus beta 2 minus beta 0 would estimate the post effect. For the group B, I can then think of beta 2 plus beta treatment would estimate the post effect. If I now think of DID, it is nothing but beta 2 plus beta treatment minus beta 2. And hence, this is difference in regression framework. Clear? Simple. Right? Pretty simple. So given this is what I obtain the difference in difference estimate by beta hat by running this regression, and I calculate the differences in the mean of the treated with the control and before and after, and I call that as beta hat treatment. Okay. So note, how does it work? Why the hell that covariate something is there in crazy LaTeX? Anyway, so it nets out both the group specific and the time specific effect, can be extended with covariates, well as remains, can be extended with further covariates because the gamma xit I can easily have, and well as interpretation does not get changed. Recall, this is what we did more in terms of the actual number, effect of minimum wage increase in terms of New Jersey. That is where we started with an example on employment, February 92, November 92. And then if you see, because of the minimum wage, the employment actually in Pennsylvania, it has decreased by 2.1%, whereas in case of employment has decreases. In case of New Jersey, it has increased, right? So minimum wage basically, or increase in minimum wage, acts something like an incentive for low wage worker to come back to the labor market. And if you look at the unemployment benefit literature in case of developed market, then you will observe that in some of the European countries, they have changed the unemployment benefit pattern, that you cannot just get forever unemployment benefit. After every 2 years, you need to prove that you have tried to get a job, otherwise it would go away. Keir Starmer in case of UK is trying to do it, but there is abnormal pressure and I have no clue what would happen. Okay, clear? So that's how the welfare mechanism goes in those countries. So note, a better graphical illustration is in terms of my treatment has taken place. I have the observed PA, observed NG, and then the counterfactual NG, and the difference between observed NG and the counterfactual NG is nothing but my beta hat treatment. And recall, I already tried to explain you what does the beta 0, beta 1 and beta 2 implies in terms of my this table over here. Clear? And that's basically a simple graphical illustration that what can you think of the labor supply or the employment in terms of the change in the minimum wage. Okay? Yes, please.
Before the treatment, EA and NJ were not going parallel.
Yeah.
Okay.
No, before the treatment, I don't know.
Okay.
But then you observe that there is a decrease in terms of labor supply in case of PA, and there is an increase in labor supply in case of New Jersey. Clear?
So on this right side, you have mentioned the counterfactual NJ and you have mentioned beta treatment on the right side. Blue color beta treatment.
Yeah.
So counterfactual NG meaning what do you mean by your counterfactual?
That there are these guys who did not get the impact before or after the treatment has happened.
Of New Jersey.
Of New Jersey. Because I want to create a counterfactual not only in terms of New Jersey, I can do that in terms of, so that's it. This table looks very simple, but this table is actually the key. Because I am trying to think of expected value of the outcome under different circumstances. The first circumstances for both group in prior to the treatment. In one group, the mean is beta 0. In the other group, the mean is beta 0 plus beta 1, which gets reflected in terms of the intercept in this graph. Then if I go back and then the treatment took place, right? For one group, the control group, it still remains as beta 0 plus beta 2. For group B, it now becomes beta 0 plus beta 1 plus beta 2, plus I get an additional benefit, which is beta treatment. So what I then can do for the control group, I try to think of the outcome, the expected outcome between the post and the pre, which is nothing but beta 2. Then I compare that of the outcome of the treated between the pre and the post, and that would be equal to beta 2 plus beta treatment. Now I take the differences in the outcome between New Jersey and Pennsylvania, and that's nothing but my beta treatment, and that's the graph is trying to tell you. Sorry. Clear? Okay? So given this, I have the more general setup. So no two periods T01 units I are either they belong to treatment or they belong to the control. Outcome YIT I observe for every guy I1 to N. I define the treatment effect when DI takes the value of 1, which was in our simple case WI is equal to 1. I then create the counterfactual of expected value of yi 0 when di is equal to 1, which I never can observe, right? And then I want to impute it by what? By the expected outcome of 0 conditional on di is equal to 1, which I can decompose into two parts. First part, initial state of yi 0, but d still takes the value of 1. The next part is nothing but the differences between the expected outcome, which is y1 and yi0, but under the assumption that as if there is no treatment, clear, which is di is equal to 0. Okay. Recall di is equal to 0, no treatment, di is equal to 1 is the treatment. And I want to think of the impact of yi1 given the fact di1, which has two parts. One, nothing has happened, what would be the change in the mean between the two guys, yi1 and yi0. And then I can add the mean of the yi0 as if the treatment has happened, right? Clear? Okay. Because you see that the entire effect that we are talking about is in terms of the additive models, isn't it? Right? It is beta 0 plus beta 2, beta 0 plus beta 2 plus beta 1 plus beta treatment. Okay, clear? Fine. So that's how we want to, and even if you think of my ATE was nothing but the weighted average of ATT and ATU. Clear? Where the weight is nothing but equal to rho. You can think of one way that I am going to put exactly the equal weight on both parts, right? On the part of ATT and on the part of ATU. Okay. What do I mean by the parallel trend? So the parallel trend is basically trying to think of, I take the expected value of the difference between the two, yi1 and yi0, when the policy took place. And then I take the expected value of the same, but when there is no policy. And I claim that the expected trend of the two is exactly, or the expected value is exactly the same. So they are kind of parallel before the treatment took place, but then after the treatment, their pattern, their way they behave would change. Clear? Fine. So no anticipatory effects. So yi0 is nothing but equal to, then would be equal to yi01, because there is no anticipation that I expect, right? So given this, I then can think of my tau. Your question is nothing but, if I write that as the additive one, I want to net out the effect, and hence that is nothing but my average treatment effects. So it is nothing but the expected value of the difference between the two occurrences, di is equal to 1 and di is equal to 0, between the treated and the untreated. Clear? Fine. Okay. What is this? Oh, that's your papaya. Yeah. I remember suddenly. So whenever we are having tea, he is having papaya. So today, how many papayas you have? I mean, there was only one break, so you must be having, oh, you have finished the dabba. That's good, that's good, that's good. So after 3:30 or 4 o'clock, when we will have another cup of tea, you will drink water. Huh? We can do a DID, that having the impact of papaya on the learning ability. Right. Right. I'm sure it is positive. Otherwise, why are you taking the papaya? Or there could be an anticipatory effect about having more papaya so that you can learn it better even tomorrow, right? So that's what the policy shock is about. Okay, clear? So, fine? Okay. I think that's why Leeds student likes me. I just can relate very quickly. Okay. Because when I teach them Kuntakar condition, you know Kuntakar condition, right? So the way I teach Kuntakar, I introduce the Kuntakar in a very different way. I think of the baseball cricket of England, right? They come and they hit. That's the baseball. And what they do, they don't know where to put which player in which occasion, right? So if you agree. So then Ben Stokes generally is the moving man, right? Where Ben Stokes would bat. And that's nothing but the Kuntaka trial and error solution. So you try Ben Stokes as number 2 and then it didn't work. Next game with that kind of chase, you may try Ben Stokes as number 3. If you win, it is optimal, and hence you don't have to reiterate your inequality optimization problem anymore, and hence that's the solution. All you need to think of that the solution satisfies the constraint in terms of you have 11 players and you did not cheat in the ground, right? That's your 2 Lagrange multiplier, which must be positive always. Clear? So that's how I introduce the Kuntaka. So that's what, or I create an example in terms of Premier League, that the formation of Manchester United when they play with Manchester City versus Arsenal. I'm a big fan of actually of Liverpool in that way. Clear? Fine. So key assumption. So note, we talked about it, anticipatory effect, parallel trend, and we define the DID again. What I then want to think of, and to introduce you the very, very simple estimator. Very simple estimator is nothing but my 2A fixed effect model. Recall in the morning, I have this aggregate shock problem, right? We have introduced you 2A fixed effect model, and I'm going to extend the 2A fixed effect model in terms of a DID framework. What am I planning to do? I have the sample analog of tau ATE in terms of tau hat. What is my tau hat? Tau hat is nothing but observed mean of y went through the program, right? So y bar 1 1 minus y bar 0 1 control, and then y bar 1 0, right? And they didn't get the treatment but belong to the treated unit, minus what? Minus the one who is in the control and therefore never can get exposed to the treatment. Equivalent regression, unobserved heterogeneity, alpha I, unobserved aggregate shock phi t. I then have this interaction term, and then I run simply this regression without the control or with the control, whatever way you want to think about it. And I would be interested in the coefficient of the betas. Clear? Fine? So that's how I do it. Simulated data, I have some example with the simulated data. That's my model, and then I put some values for my phi 0, for my phi 1, for my beta, and for my error term with a normal mean 0, variance is 0.2. And then I have my alpha I as what? As distributed with mean 2 and variance of 0.5, and it's a normally distributed guys. So this is my simulated data. So I have IDs, I have T, I have treated, I have treatment, I have expected outcome. Clear? All I do, I set it up as a panel. XT set, ID is my cross section identifier, T is my time series identifier. I have only 2 period. T is equal to 1 or 2. I then just run a regression of XT reg y I dot T and then the treatment. And I put FE as because I want to control for unobserved heterogeneity at the cross sectional level. I dot t, remember, is taking into account of the aggregate shock, right? I have 2 time period, so therefore I will have only one dummy, which is 2 dot t. And note, my treatment is nothing but 0.295 estimated with some standard error. Intentionally I try to show you that the impact is positive and significant, and therefore I will say that the treatment occurs even after controlling for the unobserved heterogeneity, not only at the cross-sectional level, but as well as at the after taking care of the aggregate shock. Clear? And total observation, I have created 20,000. I have 10,000 group, and observation per group is equal to 2. So my n times t is nothing but 20,000. 20,000. Clear? N is equal to 10,000 and t is equal to 2. You see that? Yeah. So treatment is being introduced already by the interaction. Okay? Clear?
So here, treated means
I got the treatment.
Like New Jersey and
Pennsylvania. So New Jersey is my treated group. And treatment is nothing but policy times I belong to New Jersey. Clear? That's like the time effects. So that is why I have 2 time period. Time period 1 acts as the base category, and I want to have only 2 dot t. Fe controls for your alpha I. Phi t is being controlled by this guy 2 dot t. Treatment is nothing but the indicator times I belong to New Jersey. Clear? Fine.
If you have more than 2 periods,
then you have more dummies.
Just time train.
Yes, the time dummies, not the train. The time dummies, right?
But the coefficient that you are getting, it is time train.
The coefficient I am getting is the treated, the treatment happens times the treated units. And then if you have 4 time periods, then you will have 3 of those time dummies. Assuming 1 would be your base category, you will get an estimate for 2, you will get an estimate for 3, you will get an estimate for 4. Because note, these are dummies. If everybody belongs to year 1990, then it is equal to 1. Rest of the year is 0. Then 1991, then 1992, then 1993. And the 1990 would take the value of 0, 1991 only take the value of 1, and then 92, 93 would take the value of 0 again. Right? That's the time dummy features. Okay. Clear? Difference in stata, right? So what I do, I started looping this up in terms of t is equal to 1, 2. Then I have the g, which is the treated versus the control, 0, 1. I basically summarize my y by quietly summarize if t is equal to t and treated is equal to g, and then I calculate the mean. And then all I do is mean of y if time is equal to t, and treated g if it is time is equal to t, but whatever the group is they belong to. So all I try to get mean of y if time is equal to 1, treated is equal to 0. Mean of y, time is equal to 1, treated is equal to 1, which is this guy. Then time 2, treated 0, and then time 2, treated 1. Clear? Fine. So all I then want to calculate is the difference between them. So I want to take this guy, this guy, this guy, and this guy, and then I want to display my beta hat, which is 0.295, and that's exactly as I get if I use the command in stata, right? So basically what I want to think of that, like, can I understand what is DID instead of blindly following what stata is doing? And that's one of the way you can simply think of doing it. And it's a very good exercise in my mind to do it exactly in this way, because then you really understand your slides better. Clear? Fine? Fine. I'll take 2 minutes halt and then I'll start. Sorry. मेगा देखो तो एक कॉफी मिलेगा कि नहीं.
Seminar at 3:30.
No problem.
So I'll sit there and we'll go from there.
Hmm.
So once you finish, would you like to go back or would you like to?
To meet me, I have to meet Meghna for some time.
ठीक है, I'll be in my office only after 2 o'clock.
This is better. Shit. Oh. क्या हुआ?
So you want to try some chicky? Jaggery premix. Sweet.
कहाँ से लेकर आया?
Puna. Soft.
Not bad.
You can have more.
That's it. No, no. Then I'll become Kalindi. Oh God. Really tired. बहुत देर हो गया. Okay, so more on DID, we can think of if there is two time periods, more than two time periods, and then I can think of that the treated and the control units, they got exposed at different point of time. So I want to think of something like staggered timing or staggered treatment timing along with heterogeneous treatment effect, along with heterogeneous, thank you. Okay. So the way then I want to think of that, I want to start with that a group is being treated, a group is not being treated. What happens eventually if all group gets treated, which I am going to talk more in terms of event study analysis. Clear? I'm going to give you a very simple application of wage effects of motherhood, and then I'm going to think of that what if parallel trend assumption is getting violated. So I'm going to condition them on covariate and then testing for pre-trend. Finally, I'm going to talk about what I call as synthetic control method, but perhaps not today, when I do more like propensity score tomorrow. So staggered timing. What does the staggered timing means? We have three groups of people. We got exposure at three different time period. One group may not get any exposure. One group got the exposure in 2016. The other group got the exposure, say, in 2020. So group which got the exposure in 2016, how does their impact on them differs from the group which got exposure in 2020. Clear? Fine. So that's what my staggered setting tells me, because everybody doesn't get treated exactly in the same way. So note one way to think about it, panel of counties in UK that enact legislation of interest at different point of time. If you think of in US, there was, what is that law? I forgot. So suppose I now have time is equal to t is equal to 1 to capital T, unit receives first treatment in period GI and continues to be getting treated for all over the time period. I can then think of that if I think of my static TWFE specification exactly as before, we assume parallel trend and no anticipation assumption hold. This TWFE regression is problematic. And why is it problematic? Because different group got exposure at different point of time, right? And then the time differs since treatment or across unit. Effect of legislation may be different across county over time since adoption, right? Right. So given this, it's too hot. So given this, what I then want to think of, heterogeneous treatment across time. So suppose there is heterogeneity in time since treatment, units have different effect, tau s, in the Sth period after the treatment took place, right? So I'm going to estimate it that beta post is nothing but going to be an weighted average of different unit received treatment in different time period with their respective weight, and the weight would be nothing but the share of them in the treated unit, right? So you can think of N1 is, or W1 is the group 1 share, W2 like this, and W1 beta 1 hat, W2 beta 2 hat would be nothing but my overall estimate. Clear? Fine. So given that possibly beta post may be negative even if all the taus are positive, and that's the way I want to think about an example, that it could turn out to be that overall effect is positive, overall effect is negative, but all the tau s, they are positive. So what I want to think of, group A untreated in periods 1 and 2, treated in periods 3. However, group B untreated in period 1 but got treatment starting from period 2. And there is definitely a difference between group A and group B. Clear? So TW estimator, uses units treated in earlier periods as control for later treated units, and I can then think of all I need to do is a dynamic TWFE. So different dummies for different type of staggered setting. If I do that, then one of the example is 1,000 workers observed between 2001 to 2010, annual workshop to build network, groups never treated, group B treated from 2003, that is my early treatment, and then 2007, that's my later treatment. Workshop raises wages 4% initially, 15% after 4 years. Initially 4% means 23, and then 2007, which is like a gap of 4 years. Right? Clear? Fine. So given this, I then want to think of an illustration. Okay? So I think it's a nice graph, and thanks to Leela. So group A never treated. Right? Group B is the early treatment, and group C is the late treatment. So if you think of the difference is 0.15 because 15% jump in the wages. If you think of the other guy, it is something like 0.4% or 4% jump in the wages. Clear? So the way I then can think of, I want to have a dummy for group B from 2007. I want to have another dummy for group A from 2003, and I then want to compare that with those guys who never receives the treatment. So the way then I want to think about it, this is my group treatment event time. When did I get the treatment? You see that? -6, -5, -4, -3, -2, -1 for group A because they belong to group C. You are getting it? Yes. It should be 0.7. Possible? Because I know group A never treated, so I'm going to compare that. I'm going to compare because if they did not get anything anymore, they would remain here. But they got the treatment in 2007, so they jump up, and hence I want to take the difference between these two guys. Clear? And here I want to take the difference between these.
So group B got treatment in 2003, right?
Group B, Group C, and the group A. So group A constant. Group B has a jump 2003. Group C is having another jump in 2007.
But why then in group B also has a jump in 2007? There might be some anticipation effect.
That could be there. But I am just thinking, I think the leveling would be group C over there, and that would be group B. This one should be, and this one should be. I think it got interchanged. So note here, I have the group C 2001 to 2006. They are all zeros. Why? Because they are the one, they got the treatment in 2007. Clear? How many years I left without the treatment? From 2007 until when I start, which is 2001. So you see that event time -6, -5, -4, -3, -2, -1. Clear? Then I have, then how many years I have been into the treatment? 2007, 8, 9, and 10. I have that exactly in that way. 1, 2, 3, 4. Think of group B. Group B got the treatment in 2003. Clear? So then time to event is -2, -1. Event took place in 2003 over here, and it is I am being exposed for 8 years, whereas I am being exposed for 4 years. Time to go -6 to -1, time to go -2 to -1. Clear? So that's the way the frameworks work. Static TWFE, nothing. I just want to implement with this. But when I want to think of that TWFE in a dynamic sense, all I want to do, extract my dependent variable log wage, I dot event time. how many years I have to go through before I get exposed to the treatment. And hence, I also have something like the year dummy to control for aggregate shocks. Clear? So, then if I believe in this, then I can think of what happens in an average. Static is telling me 0.014 is the total effect. But the dynamic is telling me 2 years before, the effect is not significant. Year of treatment, it is significant, and then 1 year after, 2 years after, 3 years after, 4 years after, it started becoming more significant. Number of observation is 10,000 in both cases. Clear? So that's one of the advantage of doing the dynamic. I can actually figure out that the entire effect is maybe remains. First, you give a shock, the impact is there. Then the impact a little bit reduces, but when people started benefiting from the program, then there would be a huge impact, which is 0.175. And that's how this guys tells you to do. Note the dynamic TWFE can also put negative weights when heterogeneous treatment effect across adoption cohorts, okay? Because I can have. So how do I want to think of report degree of heterogeneity in treatment effects? That would be necessary for the estimated treatment effect to have the wrong sign. We talked about it could be negative. Reports weight that beta post places on pairwise comparison, because it's the aggregation rather than period-wise estimate. New estimators, several of them are coming up. Callaway and Sant Anna is quite famous. You can do it in Stata by CSDID. Then there is something like Stack Dev by Sengiz Dubé. Then there is another one which is DID imputation, right? So these are basically the Stata way of doing this staggered setting. Last day of the class, I'll give you more on staggered with a real life example with one of my students, what we did. Event study. So note, and what is an event study? An event study is nothing but a difference in difference. I can visualize it, okay? Where at one point of time, I would think of that everybody get exposed to the program. So in that way, there is no pure control. The group of the control changes over the time period, okay? And at the end of the day, I'm just going to think of that everybody is receiving the treatment. Example, we want to estimate the effect of parenthood on women's earning using a panel of women's earning over the time. The authors implement basically a difference in difference comparison of women who remain childless and who became mother. So control versus the treated. Forward may differ from the later because they also affect the earning, which could depend on time varying unobserved heterogeneity. Recall my aggregate shock, right? When am I getting pregnant? Or compare the trajectory before and after motherhood as well as across women becoming parents at different point of time, right? No, it is not true that everybody would become parent at the same point of time. They are becoming parent at different point of time, and which allows to event study kind of framework. Yeah, fine. Stock split happens, mergers happen, acquisition happens, but it happens at different point of time. So I can allow also for visual inspection of parallel trend assumption. It's a very famous paper by Cleven which talks about children and gender inequality evidence from Denmark, and basically the figure I will show you is over there. So I'll come to that. So the ideal experiment, in one way to think about it, the impact of children would to be randomize the fertility. Clear? Instrument for the number of children such as twin birth, one of the classic example or classic instrument is the twin birth, and sibling sex mix that's being used for the new birth. Such instrument cannot provide estimates of the total effect of children. So what Cleven did and adapt an event study approach based on sharp changes around the birth of the first child for mothers relative to fathers. Clear? So that's what the parenthood comes, okay, on the earnings of the mother. For each parent in the data, denote the year in which the individual has his or her first child by t is equal to 0. And then I want to index everything with respect to 0, time to go or time after. Clear? And then baseline specification, a balance of parents observed every year, 5, as I said, time to go and time after, right? 5 years before having their first child and 10 years after. So time to go and time after, right? We call 2 years before, then year 1, year 2, year 3, and goes on, so on and so forth. Clear? And that's the graph. So time to go, -4, -3, -2, -1. Event happen, first childbirth. And then I want to observe them over the time period, the male and the female. If you look at the male, it almost remains the same. If you look at the female, it dips. And then after 1 or 2 years, it starts again picking up, right? I mean, that evidence, they started at the same point of time. When the childbirth took place, the female wage earnings relative to t is equal to 1, right? It dips, significant dip. Then years passed, it started slowly catching up. But even after 10 years, it still did not come back to where it started. And hence, they call it is nothing but long run of child penalty or having a child. Clear? Which the female is suffering, and they estimate it to be 0.094. Okay? Clear? Which is not a small magnitude. Shall we proceed? Event study design, as I said, all units would be eventually treated. So there is no concept of pure control group. No group is a pure control. Okay? Then cannot have both time and unit fixed effect and full set of event dummy, because they would be collinear with each other, and need to exclude both the baseline period, which is the time period prior to the treatment. Okay? And problem with staggered timing also apply to event study, and then perhaps we need to think of the heterogeneity in treatment effect, and that's what I'm going to then do in terms of staggered setting. Okay. What we have done, we have tried to show you difference in difference is quite powerful, does not require a lot of times random assignment, but rather implementation of policies that differently affect two groups of people, the treatment group and the control group. Can be a great application of big data with convincing graphs that highlight your application. Clear? And then I can think of partial test of identifying assumption, growing literature on staggered timing, but not necessary to engage if only 2 periods. 2 periods, there is no point of doing staggered, right? If you have more than 2, at least 4, 5, 6 periods, then it is makes sense definitely to do the staggered setting. Okay? Think about what your counterfactual, identifying assumption in each setting, and then highlight them. Do not hide from the others that you don't want to, I want to get it because I want it, right? So clearly telling what are the assumptions that would help you. Selection bias. Note, I need to control for observed or unobserved confounders, and the way I then want to think of different process. One of the process we talk about is the regression adjustment. In regression adjustment, what we do, we run 2 separate regression, one for the treated group and one for the untreated group. So for the treated group, it is beta 1 is the coefficient. For the untreated group, the coefficient is beta 0. Then I want to adjust this by the predicted value of the group 1 and the predicted value of the group 2. So that's my y1 hat minus y0 hat. I take the difference across everybody, I take the average and I call it average treatment effect estimated via regression adjustment. And that's why I'm doing two different regression. Clear? Fine. So given this, I can also do something like more on propensity score. Tomorrow, I can do something like inverse probability weight, where I estimate first a model in terms of a logit and probit. I then try to think of probability. What is the probability that the treatment would take the value of 1, conditional on the set of the explanatory variable, which is x, and then I calculate the IPW80E in terms of this weighted average estimator by taking the predicted value from my probit regression, which is E hat x. Recall E hat x can occur under two circumstances, or when W is equal to 1, not like the W is equal to zeros. And that's what I do, right? So E hat in one portion, the symmetricity would allow me 1 minus E hat. Note both the logit and the probit are symmetric in nature. Both the logistic distribution and the normal distribution, both of them are symmetric in nature. Clear? Fine? Fine. doubly robust, what it does is basically it combines RA and IPW. Consistent advantage is that if one of the model is correct, then it would give you the consistent estimator. So more popular compared to IPW adjustment or regression weighted adjustment, more popular is to use the doubly robust, because with the assumption at least one of them is going to be consistent. Clear? And that's how it does. Basically, again, you can see I have y1 hat 1i, y hat 0i, which is my regression adjustment. And then I have the other part, which is the IPW kind of adjustment. And hence, I can calculate them as nothing but mu 0 hat under nobody got the treatment, or some people did not get the treatment. With those got the treatment, recall the denominator, I have 1 minus E hat. And here, for the guys who got the treatment, I always have E hat, right? And then the difference in the mu 1 hat and mu 0 hat is nothing but double robust estimator. I can easily do it in stata. First, I regress, W is equal to 1, W is equal to 0, calculate y1 hat, y0 hat, take the difference, my regression adjustment. In the next step, I can do either logit or a probit. So I run a logit of y on x1, w on x1 and x2, predict my p score, propensity score, get my weight, which is w over p score, plus 1 minus w divided by 1 minus p score. Recall E hat 1 minus E hat xi, and then use that as your sampling weight. Pw is equal to our probability weight, or sampling weight is equal to your wt, and do the model. In case of doubly robust, the way Stata does it is IPW, inverse probability weight, combined with regression adjustment RA, and where I am regressing y on x1 and x2, x1 and x2 as my RA component, and w on x1 and x2 as my IPW component, and I want to compute the ATE in this case. Clear? Pretty simple stuff in terms of Stata. Okay. I don't have that much time. I'll come to that tomorrow. Instrumental variables, I can think of the local average treatment effect. W is, that is a problem with LaTeX. I'll correct all those. It's not a problem. W is systematically related to your W0, or the state of the affair S0 and S1, even after controlling for X. And in this particular case, I just want to think of not the average treatment effect, but something like the local average treatment effect. So in one way, you can think of the LATE, or the local average treatment effect, is the use of the instrumental variable. Clear? How do I do it? I introduce you two different concepts. One is compilers versus the defiers. It's straight from Ulrich. Some units made eligible for the treatment will choose not to participate, right? I am eligible, but I don't want to participate. Possible self-selection problem. Then a compiler is any unit that compiles with their assigned assigned, what should I say, treatment status, right? So I can think of the assigned eligibility. On the contrary, a non-compiler is any unit that is not a compiler. And then I can have a defier is a subcategory of non-compilers where a unit will choose to do exactly the opposite compared to their eligibility. So I am eligible, but I am not going to do it. So I belong to non-compiler, not because I did not qualify, but because I selected not to be qualified. Clear? So these are the concepts that we want to think of: compiler versus non-compiler versus the defiers. There are assumptions as we did in case of instrumental variable. Z has no direct effect on the potential outcome, right? Z, which is my instrumental variable, independent of W0, treatment status, and outcome, which is Y0 and Y1. Existence of compilers, there are some units with W1 is equal to 1 and W0 is equal to 0, but definitely the probability of W1, which would be greater than the probability of W0, and that would be, or the probability of W1 greater than W0 should be a positive event. And then the monotonicity rules out the possibility of the defiers, where the probability of W1 greater than equal to W0 is a sure event. I cannot have that. Clear? So I just eliminate the probability of the sure event. Assumption, under the 4 LAT assumption and random sampling, I can simply take the lambda hat LATE as the mean of the two, mean or the ratio of the mean of the two, Y1 bar, Y0 bar, right? And W1 bar minus W0 bar. Estimate the IV using ZI as an instrument for WI. And then step 1, I regress Wi on a constant and the set of the explanatory variable, which is Zi. Clear? And I would end this of a huge reading of Introductory Econometrics by Ulrich, chapter 19. Clear? Tired.
Can you explain on compliance?
Sure. Yeah. So basically, I am trying to think of, there could be units, they are voluntarily decided not to participate in the program, even if they are eligible to participate. Right? And there could be units, they have participated in the program, given the fact they are eligible to participate. So compiler is the unit that compiles with their assigned eligibility. I am eligible, I would participate. Clear? A non-compiler is someone who is not eligible to participate. But defier is a small group of people in the non-compiler group. You would observe them as they did not participate in the program. But they differ from the non-compiler because they are eligible. Their voluntary decision is not to participate in the program. Right?
Yes.
And if you guys do not mind, I will give you a real life example. I cannot mention the name of the student, name of my friend. I mean, he's quite senior to me. And the real life example is from IGIDR, where I belong for 8 years in payroll, but 6 years really I used to teach. Like Rupayan is my student. So given that, what has happened at one point, can I switch off the recording now? Because I get very